So hello everyone, in this video we'll be solving the LeetCode Weekly Contest 477, the first three problems, that is A, B and C. So in this video we'll be discussing the solution for these three problems. I wasn't able to solve the D problem. Let us discuss the first problem first. So the problem name is concatenate non-zero digits and multiply by sum, and this is the first part of this problem. The second part of this problem was the C problem. So let us read the problem statement first. So you are given an integer n and you need to form a new integer x by concatenating all the non-zero digits of n in their original order, and if there are no non-zero digits, the x will be 0. And then they have defined the sum. So let sum be the sum of digits in x. So all the digits that are present, take the sum, and that will be the sum. And in the end you need to return the x multiplied by this sum value. So this is pretty much easy problem, just implement what it is said. So just check whether s of I minus 0 is like not equal to 0. If it is non-zero digit, then take a value variable val and multiply it by like 10, and then add that particular digit or the s of I minus 0. Keep on doing it and take the sum variable as well, where you will be taking the sum of the digits as well. So like this. In the end, just return the val multiplied by sum. So yeah, this is straightforward solution. So let us see the code now. So first we'll be converting this n integer to string. That when we'll be like checking this condition, and then we are taking a variable value and the variable sum, which is initially to set to 0. Then we are iterating the entire string. We are checking if the current digit is non-zero, then we are like you can say concatenating that particular digit into our value, that is val. So how will we do that? We'll multiply val by 10 and then just add that particular digit. So let's say currently if the value is 10 and we got the digit as like 5, so our new number would be 105. So how we are doing? We are multiplying it by 10 and then adding 5, so it becomes 105. So that is how we are concatenating the digits in like long format. And sum, we are just keep on adding that particular digit. In the end we are just returning the value multiplied by sum. So yeah, this was the first problem. So let us see the second problem now. The problem name is find maximum balance XOR subarray length. So let us read the problem. So given an integer array nums, we need to return the length of the longest subarray that has bitwise XOR of 0 and that contains equal number of even and odd numbers. If no such subarray exists, we need to return 0. So how will be solving this problem? So we have a property of XOR that any number that we have, if we XOR it with 0, we get the number itself. So we'll be using this particular property in this problem in order to get the longest subarray, I mean. So let us see the first example. So here we have first example is 3, 1, 3, 2 and 0. So we are not taking care about even and odd numbers currently. We are just checking about the XOR part. So we'll be starting our XOR value with 0, and we are just, and as we move on to these indexes, we'll update our XOR. So here the XOR value will be 3, here the XOR value will be 2, here it will be 1, here it will be 3, and here it will be 3 again. Now if we see that here we have XOR value 3 and here also we have XOR value 3, here also we have, but we need to take the longest subarray, so that's why I choose this 3. So if we have seen a XOR value previously and we are again encountering the same XOR value, so what we can say? We can say that this particular subarray XOR must be equal to 0, because we have seen that XOR of 0 with any number is that number itself. So this subarray must be having the XOR value 0. That's why we have seen the XOR value 3 again. Now let us see actually that this subarray is like 0 XOR or not. So we have 1, we have 3, so its XOR value is 2. So then we have 2 and here we have 2, so its XOR value is 0. Here we have 0, here we have 0, so its XOR value is 0. So yeah, this subarray does have the XOR value as 0. So yeah, we can say that with this intuition we can just keep track of the XOR values, and if we see that XOR value again, we are just updating our answer with the previous index that we found minus the current index. Because here you can see the initial index that we found 3 was at 0th index, and here when we find that 3 again, the index is 4. So we can say that the length of the sub array would be 4 minus 0, that is equal to 4. Now here the question is not limited to this. We need to take care about one more thing, the equal number of even and odd value. So yeah, it is simple. We can just keep an even odd counter. If we got some odd value, we will like decrement by 1. If we got some even value, we will increment it by 1. So yeah, with this intuition we will keep track of both the things, XOR value as well as even odd value. So whenever we find this pair again, where we'll be having the XOR value as well as the even odd balance same, that means we can say that we found a sub array which has the XOR equal to 0 and even odd numbers which are same. So let us just dry run on this first example and try to see how this algorithm would actually work. This particular even odd logic is also similar to the XOR logic that we have seen, like the XOR value of 0 of any number is the number itself. So similarly we can say that if we are just adding 1 if we get even value, and if we are just subtracting 1 when we get the odd value. So if we have the, let's say currently we have the even odd balance as 1, and again we find some 1 again, so we can say that okay, this sub array has equal number of evens and odds in it, so that's why it again became 1, otherwise it won't have become 1. So same analogy is used here. It is just that we are just combining both of the things inside one pair and storing it inside one map, so that we can keep track when did we find the last index. So yeah, let us dry run on this first example, it will be more clear to you. So yeah, let us see this first example, 3 1 3 2 0. So this is the array, these are the indices 0 1 2 3 and 4. So currently we are here, we current have the XOR value as 0 and current even odd balance as 0 only. We came here, initially we'll be storing it inside a map 0 comma 0 as -1, so that we can take care of the scenario where we find some pair 0 comma 0 and we can just like compare it with this particular index. It is not an index, just the starting point we can say. So this is the one thing that we'll be doing in the beginning of the solution. So currently we have the number 3, so our XOR value will become 3, and since it is an like odd number, so even odd balance would become -1. So we'll be storing this pair inside a map, so 3 comma -1, and at what index we got this pair? We got this pair at 0th index. So then we'll move forward. Here we have value as 1, so we will XOR it with the current XOR value. Current XOR value is 3 and we are XORing it with 1, so our new XOR will become 2. And since it is odd number, we'll update or we'll decrement it by -1, so our new even odd balance would become -2. So currently our XOR value is 2 and even odd balance is -2, and it is present at index 1. Then we came again at 3, so currently the XOR value is 2 and the current number is 3, so 2 XOR 3 is nothing but 1, so our XOR value is 1, and like even odd balance would become -3 because 3 is an odd number, so it is -3, and we'll just store it with the index of 2. And yeah, we'll be also checking whether we find this pair previously or not. Currently we didn't find, so I didn't show you, but whenever we'll find, I'll just show you how we'll be updating the answer variable. So then we will be coming across this 2. So currently it is 2 and the XOR value is like what? The XOR value is 1. So 1 XOR with 2. So it will give us the new XOR value as 3. So we'll update our XOR value, we'll store 3, and since the 2 is even number, so we will add +1 to our even odd balance, so it will become -2. So currently our map will be looking something like this, 3 comma minus 2, and it is present at index 3. Then we came across this number 0 again. So currently our XOR value is 3, we XOR it with 0, we again got 3. And the 0 is even number, so our even odd balance would be like plus 1 to it, so our even odd balance would become minus 1. So yeah, 3 comma minus 1, we have seen this pair before. So if we have seen that pair before, that means we got the subarray which has the XOR value equal to 0 and equal number of even and odd numbers in it. So what we will do, we will find the length of the particular subarray. And what would be the length? That length would be nothing but current like the previous index that we find the pair. And how will we find that? MP of the current pair, which will be the giving us the index. In this case it is 0, and we will subtract it with the current index. What is the current index? Current index is 4, so I minus MP of the current pair. So I is 4 and 0 is the previous index that we found the pair, so it will give us 4. So we will update our answer by 4, and we will just like, we will not store this particular 3 comma minus 1 pair again, because we need to find the longest subarray. So let's say if we just store this particular like pair in the map, so if we find that particular pair 3 comma minus 1 again in the future, so we will be comparing it with this particular index, not with this particular index. So if we find that pair, that would be wrong, right? Because let's say we find again at index 6 this particular pair, so in that case the longest the subarray would be 2, but we don't want that. The actual subarray can go as long as 0 to 6, so actual subarray length would be 6, right? Because we need to take longest pair, so we will be taking the first time where we found this particular pair. So whenever we found a pair, we will not store it again, we will only store it with the first time, so that we can get the longest subarray. So yeah, after this there is the end of the subarray. So the answer that we got is 4, and you can see the output is also here 4 as well. So let us see the code now, how the code is working. The code is similar to what I just explained. Integer n is the size of the nums array. Then we are keeping track of map, which will be the pair of XOR value along with the even odd balance, storing it with the corresponding index that we found the pair, initializing it with 0 comma 0 as minus 1 and prefix XOR and even odd value as 0, because currently everything will be 0. Answer variable also 0, which is denoting the longest subarray. Then we like loop through this entire array nums, and we keep taking XOR value, and also we are checking if the current number is even or odd. If it is odd, we'll subtract minus 1. If it is even, we'll be adding plus 1. Then we make pair of this current prefix XOR and current even odd pair. So if we found this particular pair where we have the XOR value and even odd value, if we found this pair previously inside the map, we are just updating our answer with current index minus MP of pair that we find it first time. So yeah, this is how we are updating the answer. And if we didn't find that pair previously, we will just add this entry to our map and we'll mark that this is the first time we are getting this pair, and in the end we are just returning the answer. So yeah, this was the like solution of the second problem. So yeah, it was a bit on the tougher side, because you couldn't come up with this solution directly in the contest. You need to solve these kind of problems before, then only you will have the idea, like we can just store it inside the map and check whether we got the previous value or not, and so on and so forth. So yeah, if you have solved these kinds of problems previously, then you would be easily able to solve this problem. Otherwise it would be difficult to solve. So yeah, this was about the second problem. So let us solve the third problem now. Let us see the third problem of this contest. The problem name is concatenate non-zero digits and multiply by sum, part 2. The part 1 was the problem A that we have already discussed. So let us read the problem statement first. So you are given a string S of length m consisting of digits. You are also given a 2D integer array queries, where queries of I is L of I and R of I. Now for each query we need to extract the substring S of L of I to R of I, then perform the following operation. Form a new integer x by concatenating all the non-zero digits from the substring in their original order if there are no non-zero digits, so that means the x will be 0, and let the sum to be the sum of the digits in x, and the final answer will be x multiplied by the sum. And for each and every query you need to do this and store the final answer, that is x into the sum, in the answer of I, and we need to return the answer vector. And since the number can become very large and we need to keep it in integer range, so we will mod it by 1e9 plus 7. So this is the problem statement. It is similar to the first problem in terms of what operations we need to do. It is just that now we don't need to do it for the entire string. We have been given some queries which will be denoting the substrings from the S, and for each and every substring we need to perform this following operation, and for each and every query we need to compute what we are computing in the problem A, and that just return that particular answer. So let us see with the help of first example how we can solve this problem. So we will not be considering queries for now, we are just understanding the solution part. So this is the string S given to us. Now we will understand this problem with the help of one very simple analogy, that is of prefix sums. So you might be aware of the prefix sums. So let us say you have given some original array from here, something like this, and you computed the prefix sums of that particular array, and the prefix sum is something like this. Now you need to find the sum from range L to R. So how would you compute? How we used to compute? We used to compute like that. We take the sum till R, we take the sum till L minus 1. We subtract both of them to get this particular sum. So if you have L to R this range, so what we were doing? We were taking prefix of R, we were subtracting prefix of L minus 1 to get this particular range sum. So this same analogy we will be applying in this question, but here we will be computing three things. What are those three things? First is the prefix sum for counting the sum of digits, so prefix sum. Then we'll be computing the counts of non-zero digits, so prefix count. Then we are computing the actual number, so that will be prefix of value. So these three things will be computing. Now these two things are easy. This is the main thing that we need to compute. So first let us see how the prefix sum would look like. So the prefix sum is here the indices are 0, 1, 2, 3, 4, 5, 6, 7. So the prefix sum would be 1, 1, 3, 3, 6, 6, 6 and 10. The count of non-zero digits would be, here it is 1, 1, then again 1, 2, 2, 3, 3, 3 and 4. So if you want to know the prefix sum within this range 2 to 4, so what you can do, let me just mark the indices 3, 4, 5, 6 and 7. So if you want to know the prefix sum within 2 to 4 range, so what you will do, prefix sum of 4 minus prefix sum of L minus 1. L minus L is 2, so L minus 1 is 1. So prefix sum of 4 is what? 6 minus prefix sum of 1 is what? 1. So we will be getting 5, and you can see the sum is 5. So what will be the count of non-zero digits in this? Same, prefix of count of 4 minus prefix of count of 1. So what is the prefix of count of 4? It is 3. So 3 minus what is prefix of count of 1? It is 1. So 3 minus 1 is 2, and you can see there are two non-zero digits, 3 and 2. So till now everything works fine, but the main logic is computing the value. So let us say if you are given some range 2 to 4, so how will be computing the prefix value? The prefix value is easy. This is not the important part. The important part is that how you will be computing within this range. The prefix value is very simple. You can just keep on adding value star 10 plus the current digit and so on and so forth. So you will be getting the prefix value easily, but finding in this range is difficult. Not difficult, but a little bit difficult to understand. So how will we do that? We will just see right now. So let us just compute the prefix value initially. So I have pre-computed the value of prefix of value and marked their indices as well. Now in this case, to get the number between the range 2 to 4 is not simple. We can't just do that prefix of value of 4 minus prefix of value of 1, because in that case we'll be getting the wrong answer. So here in this case we'll be getting 123 minus prefix of 1, that is 1, equal to 122. But this is not the actual answer. The actual answer is 23. You can see that within the range non-zero digit is 23. So how will we get that 23? So if you just look at the prefix of 4 value and prefix of 1 value, what we are missing? We are missing the number of digits. We can't just directly subtract 1 from 123. We need to actually make this as well the equal to the number of digits here only, here also. So 123, we need to do something like this in order to get 23, right? So we need to subtract 100. But how we can make this 1 into 100? So let us see now. So we have calculated the prefix of count previously, and why we have computed, we will just see what is the use here. So let's say we have 123, and what we will be subtracting? We will be subtracting prefix value of what? L minus 1 multiplied by, we need to equal it to the number of digits here. And how will we get the number of digits here within this range? We have already seen 3 minus 1, that was 2. So we can just say we can multiply this by 10 to the power of 2. So what we will be getting? 123 minus prefix value of L minus 1, that is 1, multiplied by 10 to the power 2, that is 100. So if we do this, we will be getting 123 minus 100, that is nothing but 23. So this is how we will be getting the intermediate value between the ranges. So this part is a little bit difficult to understand for this range, but if you can just try out with some other examples, you will get it. So let us just directly dry run this first example or the first test case in order to get the solution, so that you will be understanding in more better way. So let us just dry run on the first example. So yeah, this is the first test case. So I have just pre-computed the prefix values for sum, count and value, and this is the query. So let us first solve for the 0 to 7 query. So for the 0 to 7, the sum will be what? So let me just mark the indices as well, 0, 1, 2, 3, 4. So let me just write it with some different pen color. So yeah, we can just write it with blue. 0, 1, 2, 3, 4, 5, 6 and 7. So what will be the prefix sum value within this range? Yeah, so prefix of 7, that is 10, minus prefix of L minus 1. So in this case L minus 1 would be negative, so we will be just computing with the 0. So 10 minus 0, that is, we will be getting answer as 10. So the sum value for this range will be 10. So we got the sum value, but now we need the actual value that will be computing with the help of this count and the prefix value that we have computed. Now how will we do that? We have just learned a simple formula for getting the correct value. We'll be doing prefix value, or in this case just the value of R minus value of L minus 1 multiplied by 10 to the power of the number of digits between them. So digits between them, I am just writing dB. Now what would be the digits between them? It is simple. Count of R minus count of L minus 1. So in this case it is what? 7 is 4 and it is 0, so will not be considering. So 4 minus 0, it is 4. So total there will be 4 digits or 4 non-zero digits within this range. So how will we get the value between 0 to 7? So what is value of R? Value of R is 1, 2, 3, 4 minus value of L minus 1. L minus 1 is like negative, so we'll be considering 0 multiplied by 10 raised to the power 4. 10 raised to the power 4. So anything multiplied by 0 will be 0 only. So we'll be getting final answer as 1, 2, 3, 4. So the sum value that we got was 10, and the value that we actually got was 1234. So we just need to multiply. So 1234 multiplied by 10 is nothing but 12340. So if you just check the output, the answer for 0 to 7 is nothing but 12340. Now let us compute for the range 1 to 3. So let me just erase this part. I know it is a little bit difficult to understand, but if you just dry run, you will be easily able to understand this particular solution. So yeah, 1 to 3. So some value will be what? Prefix of 3 or prefix sum of 3, that is 3 minus what was the range? 1. Yeah, so 0. So 0 is what? 1. So we will just get the sum value as 2. Now how will we get the value within this range 1 to 3? First check the count. So count will be what? This is 3 and this is what? 1. So count will be 1. And how will we get the actual value within this range 1 to 3? The actual value that we'll be getting is within this range is what? Value of r minus value of l minus 1 multiplied by 10 to the power of count that we have just written, count. So the value of r is what? It is 12. 12 minus value of l minus 1 is what? 1. So 1 multiplied by 10 to the power of 1, that is 10. So the value that we got is 10 minus 12 minus 10 equal to 2. So the final answer will be what? Sum multiplied by value, that is nothing but 2 cross 2, that is equal to 4. And if you just look at the output, the answer here also is 4. So this is how similarly we'll be doing for range 4 to 6, but this is the intuition. So I hope you understand. You can dry run on few other example as well to get a more clear understanding, but yeah, this is how we'll be solving this problem. So let us see the code now. So this is the mod value that we are taking, this is the size of the string, and these are the array values that we have pre-computed. We will be pre-computing. This is prefix sum, prefix val, and power of 10. I have also computed the powers of 10 for so that we can directly use it when we need to compute. So we'll be first iterating on the entire string. We'll get the digit. If the I is greater than 0, we will just take the prefix of previous value, store in a current value. And if the digit is not 0, then we will add the current digit to our prefix of sum. We will take the actual value, we will compute the actual value by value multiplied by 10 plus the current digit, that is d. And we are also taking side by side mod also, so that we remain in the integer range by modding it with 1e9 plus 7. And we are just incrementing the prefix count by 1. Why 1? Because if we ever got a non-zero digit, obviously we'll be incrementing the count by 1 because we got a 1 new digit. So yeah, this is how we'll be computing prefix of count. Now we need to process the queries. So after pre-processing all these things, we are declaring one answer vector which will be storing the final answer of each and every query. Then we are computing the L and R for each and every query while iterating. So first we will take what is the sum inside this range L to R. This is simple, prefix of R minus L minus 1. And if L minus 1 is lesser than 0, we will just take 0. We have seen in the example as well. Now if the sum inside is 0, then we don't need to pre-compute the value as well, because anything multiplied by 0 will be 0 only. So we will just push 0 into our answer and continue our iteration for the next one. If the sum inside is not 0, we'll be computing the counts of digits. Why counts of digits? So that we can, if we have the prefix of R as 1, 2, 3 and prefix of L minus as 1, so we need to make this particular digit, number of digits equal to that. So we'll multiply it by 10 to the power 2 we have seen in the example. So that's why we are keeping the prefix of count. So we'll check what is the prefix of count within the range L to R. Same thing we are doing, prefix of R, prefix count of R minus prefix count of L minus 1 if L is greater than 0, otherwise we are just taking 0. Now what will be the remaining value? Remaining value will be if L is greater than 0, we'll be just taking prefix of L minus 1, otherwise 0. This is the same thing that we were doing, like prefix of L minus 1 multiplied by 10 to the power of whatever count we have. This is the same thing what we are doing here. Now what will be the final x value? Prefix of r minus prefix of l minus 1 multiplied by 10 to the power of count, the number of digits. The same thing it is written in this equation. Prefix of r minus remaining value. Remaining value is this only. I have just named it in some other variable so that it is easier to understand. Multiplied by power of 10 of whatever count is inside that we have. So count of inside is say let's say 2. So what will be the power? It will be 10 to the power 2. That will be 100. So yeah, this is what we are doing, and we are taking mod also so that we remain in the integer range. Finally, we are just like multiplying x by sum and getting our required answer and pushing it into our answer vector, and in the end we are just returning the answer. So yeah, this third question was a little bit difficult to understand, so I highly recommend you to try out entire solution that I just told you on this first example only. Then you will be able to easily understand. I myself took around 45 to 50 minutes to get up with this solution. I literally like dry run on this particular example 2 to 3 times, then I come up with this entire solution. So I highly recommend you to dry run my solution on this first example to have the better understanding. So yeah, that's it for this weekly contest video. So I hope you learned this solution. Thank you for watching.